staring at the foam slowly collapsing in a morning coffee cup, watching the water cycle over yesterday's dishes, standing on the exact same concrete transit platform you stand on every Tuesday. During these routines, the brain disengages. The physical motions continue, stepping onto the train, wiping down the counter, but conscious awareness slips into a standby mode, letting automatic reflexes take the wheel. Through sheer repetition, the walls of your own kitchen or the texture of your daily commute become invisible. You stop seeing the space you actually inhabit. The world hasn't actually run out of interesting details. Our own sensory processing software actively hides the complexity of our environment right in front of us. This editing process is a biological feature built directly into human neurology. This chart maps a biological phenomenon known as habituation. When we encounter something new, the brain registers a massive spike of energy to process it. The neural response smooths out to conserve processing power, preventing us from becoming overwhelmed by constant data. Watching the data flow, you can see how repetitive visual input gets blocked before it can ever reach the threshold of conscious thought. Unless a site presents a novel anomaly, the brain simply deletes it. Filtering out the rustle of leaves or the shape of familiar rocks kept early humans hyper-focused on actual threats. Today, that exact same survival mechanism ensures that sitting in your living room feels unremarkable. Regaining the ability to observe the textures of daily life requires a way to force the brain to bypass its own efficiency protocols. A camera lens acts as a mechanical bypass for our neurology. It strips away familiarity by isolating and manipulating the variables we usually take for granted. The first of these variables is spatial scale. Sitting next to a standard kitchen sink is an object so ordinary it practically ceases to exist in our minds: the synthetic dish sponge. Under extreme macro focus, the synthetic fibers expand. What was a flat, coarse rectangle reveals a cavernous, highly complex landscape of neon-colored structural webs. By stripping away the